raster, raster, raster. I put the import the library. Okay, so and then I simply make the raster, import all of those band. Okay, so just I put a variable. Suppose I put the variable is the raster list. I take the variable raster list. In this variable, I put all of those raster band at the same time. So I simply mention here the rs. It's my folder name, and then from this rs, I just simply copy. I copy the file name. Just simply copy the file name, paste here, and I want to make a stack. All of those total 1 to 7, all of those band, or 1 to 11, all of those band. Okay, and then I mention about the format or extension, TIFF format. So now let's check about that. Okay, what is the problem? It's an error in negative argument is not interpol as a logic. Why? Okay, okay. So in the, okay. So when you want to make the combine all of those band, then we have to use that the paste function. Okay, but you can see here when I work for the single band, when I want to work for the single band, then I use at the raster. Okay, but when I want to combine, then we have to use this paste zero function. Okay, total all of those bands. So I simply copy the same. So that's why it's showing the wrong first time. Just paste here and paste here, paste zero. So now click to the run. I hope it will work. Yeah, it's worked, no problem. Yeah, so we can get the, we can import all of those band, total 1 to 11, all of those band. Okay, so now all of this band I want to make a stack. A stack means that I want to make the combine. So just take a variable, suppose land set, and in this variable I just simply stack. So use that the stack function, stack all of those band is stored in here. So simply copy and paste it. So now it is stacking all of those band. Okay, so now suppose I want to make the band combination, such as I put here the, suppose string the land set RGB. I want to make the RGB combination, such as I put here this RGB. You can use any variable name, then call the land set. Basically this land set stored all of those band. Okay, from that I just simply choose only for the band, such as this band will be, I simply mention about the band 4 red, then 3 green, and 2 is blue. Okay, so it is stored only for the RGB, red, green, and blue. So I take the another band, suppose I take the another variable, suppose land set FCC. In this variable I just simply call the land set, because it stored all of those band. From here I just simply choose only for the my specific requirement band. It will be 5 near infrared, red, and green. Okay, so it also imported, there is no problem. Okay, so now we can create this type of band. Suppose you want to visualize this band, what you can do, just simply use at the plot. In this time, when you plot that RGB, you can see it's showing the result. This type of result we can get in here, RGB. It's showing the all of those B4, B3, and B2. B4, B3, and B2 is showing that. But I want to make the composite or combination. For that I use at the plot RGB. Okay, so now I can see what happened. It's showing only for the one composite band, but it's not showing any color because it's showing as a black color. So for that I can simply use here the visualization. So just I simply copy the previous code for the visualization. You can see the axis is the true, S is the line. I put the, simply copy the same code, simply copy and paste. So now click to the run. In this time you can see it generate the RGB color, red, green, and blue, make the RGB color, you can see. So I run the again. So previous one is the remove. Okay, so you can see it showing the result look like me here.
Yeah.
Okay, it is RGB color. Suppose you want to show the just simply copy that FCP and paste here. So now it's showing the FCP or false color composite. You can see FCP.
Oh, yeah. Yes.
Okay. So now in this time I want to create the NDVI map. Okay. For creating the NDVI map, what the approach we have to use in here. So how I can clear this? So clear all plot. Oh, clear. Okay. Okay, plot. Remove all of those things. Okay, so now I want to show only for the one plot. For that, so click the run. It's showing. You can see. Yeah, very better. We can get the very good result. Okay. So now in this time, I want to create the NDVI map for this images. How I can create the NDVI map. So vegetation indices, mainly vegetation indices. When you want to make the vegetation indices, we have to help of function. We have to create a function. Okay. In this function, first of all, I need to create a function. Suppose I take the variable name vi vegetation index. In this variable, I create a function. Use the function keyword. Okay. After that, I have to implement the three element. One element is the image. One element is the k. One element is the I. Okay. So image, img, k, and I. Then put here the curly bracket.
KEI, what is mean KEI?
Okay. K means that your band. Okay. So in this time, I need to define about the what is the K, what is the I, and what is the about that. So let's go about that. So for that, I simply define in this curly bracket. Suppose it is I take a variable. Suppose vk. Okay. In this variable, I define image and put here the k. Okay. And then take the another, suppose bi, take the another variable and call the image and put here the I. Okay. And finally, I take the vi. In this variable, I define such as vk minus vi, then divided by vk plus bi.
Yes.
Okay, so in this time I create this function. So in this time I create this function, but I don't know what is the bk, what is the bi. So in this time, this function I need to add with my image collection. Okay, so what can I do for adding this function? I just take a variable, suppose ndvi. In this variable ndvi, and then I simply call my function variable name. This is my function variable name vi. Simply copy and paste here. And now in here, I need to mention. I simply call my Landsat image. You can see I already create the Landsat image stack. All of those band. I simply copy the Landsat and mention in here, and then put here the band name. I put here the near infrared band B5, and red infrared is the B4. Okay. So now Landsat image, from the Landsat image B5 and B4 add with my function which I created. So now it display the result. I simply run the code. Okay. And finally, we also try to show the result. It also run. And finally, we try to plot the NDVI map. So for that, use here the plot function and plot this NDVI, this function. And then I add the color. So use here the color. Okay, so we tried without color. What the you can see. Click to the run. In this time, it plot the NDVI without. You can see we can get this type of result. And finally, we can also add here the title about that, and also add the color legend. Also, you can see already show the legend in here. So in this time, we add here this. For that, we can simply put here the COL and use here this color. I put here this REV. And put here the train color. So train colors 10. Okay, so there are total 10 types of color I want to add in here. And finally, I also put here the main for adding the title. So main we use for adding the title. I mentioned the title in here. Suppose I put the title, it is that land set NDVI. Okay, just put that. So now click to the run. This time we can get the result look like that, you can see, and it showing the result for land set NDVI. Okay, and finally we can easily export this map as a image or TIFF format or PDF, or also zoom in. Click to the zoom in, then we can get the result look like that for the NDVI map. And from this, please.
How we can add this is coordinate grid in this picture?
Okay, so grid means that a specific latitude and longitude. Yeah.
Yes.
Okay, so further class I also talk about for the grid. How can we add the grid about that? Okay. So how can we? So basically, in this time we can take about the NDVI map, but it's also possible to add the grid line and make the map for your research paper or presentation work. We can easily create that.
Okay.
So in this time, from this NDVI map, we are also do for the lot of analysis. Suppose you want to apply the thresholding and choose only for the pixel value which are the greater than 0.5 or 0.4, you can choose and make this map for the only for the vegetation. So from this map, we are also applying the different types of analysis, such as suppose I want to, okay, it's a one approach for creating the function and add this function with your image and mention about the band name, as well as another approach. It has the another approach is that for another way. Suppose take a variable, suppose vi2. In this variable, just put here the function. Suppose put the x and y, and make the curly bracket. In this curly bracket, just put here the x minus y divided by x plus y. Okay, after that just use a function. Just take a variable, suppose NDVI to take the variable. In this variable, just use the function overlay function. Okay, overlay function, and then call the land set which is stored all of those band. From here, I just choose the band 5 and use here the comma, and call the land set, and choose the another band 4. Okay, and finally you have to define here the fun function and call the function variable name vi2. Okay, this is the function variable name vi2. So this is the another way for creating the NDVI or calculating the operational mathematical or raster calculation in R. To run that, okay, it will be working. And finally, we can easily display the result. Same approach. Just I simply copy the same code from here. Simply copy and paste. In this time, simply just copy the variable name NDVI2 and paste here. Okay. So now click to the run. You can see I can get the same result. We can also get. But this is another way. So just simply create a variable name, put the function keyword x and y. In this curly bracket, just define your x minus y. Suppose near minus red divided by near plus red, this function, and then use the overlay function. And after that, call the landset 5, comma landset 4, then fun function. Which function you define this variable?
Yeah. And for other vegetation index, the
same approach for the NDWI or EVI. Okay, just same approach. And this approach is easy way. I think it's a very easy way. So that's why in this time we can get only for the two element x and y. Then we can simply put our equation x minus y divided by x plus y. After that, overlay function, then define about the what landset 5 for the x, landset 4 for the y, and then fun function, put here the function variable name. So then it's a very easy way to create this type of raster calculation or calculating the indices. Okay, not only for that, if you want, you can also make the histogram. Suppose for the, you can use here the different types of range. Suppose 0.5, how much frequency distribution of the NDVI values. We can also create the histogram. So for creating the histogram, we can simply use here the function. It's called the hist, and then call the NDVI. Then I simply print that. So now it creates the histogram, but this chart is not good very well. So in this time, I can simply add here all of those things. Then I can get the better understanding about the chart. For the NDVI histogram chart, it's showing the frequency and also showing about the pixel value of NDVI X column. Okay. So for that, we can simply add here the sum option. After the NDVI, I want to add here the suppose title. Suppose I main. I put the title such as a suppose distribution of NDVI values. I put the distribution as well as I also put here the another thing. Suppose X lab mainly X axis. It's showing the result for NDVI. Okay, and Y lab it's showing the result for your frequency. So use at the frequency. Okay, after that Y lab we can color. So we can use at the color. We can use at the any color for the bar column chart. We can use at the suppose wheat color. Okay. After that we also use here the suppose X limit. I put the X limit, X lim. Put here the C. I put the X lim such as a vector. So use here the C X lim. Suppose I put here the X lim range negative 0.5 to 1. Okay, the X lim. After that, I put here the break for the bar column chart. I want to create the bar column chart. So that's why you need to make the break between the each bar. So just put here the breaks and breaks suppose 30 pixel. After that, I put here the XAXT and put here this value such as N. Okay, and then finally we can, after that we can simply add here the axis. Use here the axis such as side, one side, and then put here the AT. Put here the sequence SEQ sequence. I put the sequence such as negative 0.5, then 1, then 0.005.
Okay.
Sequence pixel value about that NDVI, and put here the levels. So use here the levels and make the sequence about the levels SEQ sequence. So same, put here the value negative 0.5, then 1, then 0. Sorry. 0.0. Okay, so now let's see about the result. So print, select, and click to run. Okay, so now I can say I can get the result look like that. So in this time it's showing the frequency and it's showing the NDVI. Okay, so in this time from here we can get the 0.25. It is the highest distribution or highest 0.25. Okay, and in this time you can see here basically when I go to the left we can get the low positive value. Okay, so basically low positive value, we can get the low value, we can get the negative value. Okay, so this negative value means that it's showing it's not a vegetation, it can be water body, it can be other feature. But when I go to in here, then I can get the positive value. Okay, this positive value identify about the high positive value. Okay, and we can get this type of positive value. Supposing 0.7. Okay, it's one kind of highest 0.85 the dense vegetation. Okay, so this type of bar column identified the specific NDVI pixel value and their frequency about the 0.5. How much frequency histogram I can get in here. Okay, so it is the distribution of NDVI values for this region. Okay, so as well as we can also do for the lot of analysis only for the NDVI. So this type of analysis we try to complete it our further next class, such as NDVI thresholding and supervised and supervised classification using the satellite imagery. So further class we also try to discuss about our other topics for this machine learning, or also our studio for the remote sensing analysis. We try to discuss the further class. Okay.
Okay.
Okay. So in the meantime, I also send you the today's recorded video class and also send you the today's practice code. So you also try to practice, and you also try to download the satellite images. It can be Landsat or Sentinel, but this format must be TIFF. Okay. So because raster image, this raster library only supported the TIFF images, TIFF format images. So try to do that, and face any problem, then let me know. So then I also try to discuss about the other time. Okay.
Okay, thank you so much.
Okay, thank you.
Thank you so much.
Okay,
Yes.
thank you. Have a good day. Okay,
You
bye.
too. Thank you. Bye bye.
Bye.